All right, we're doing 8-1 on page 234. I decided to show you guys number 2 because 2 has some more steps involved than number 1 has. So number 2, we want to start out by graphing like we've done before for slope-intercept form. I've got to first put this in slope-intercept form. So 2x plus y equals 4. I can rewrite that by subtracting 2x from this side, subtracting 2x from that side. I get y equals negative 2x plus 4. And now it's in slope-intercept form, so I can graph that now. Negative 2 is saying the same thing as negative 2 over 1. Negative 2 divided by 1 is still negative 2. So now I can put this into my graph using slope-intercept form. My y-intercept is this end part here, the plus b, so plus 4 in this case. So on my graph, I'm going to go on the y-axis here. I'm going to go up 4, so 1, 2, 3, 4. Is where I'm going to start, and my slope is rise over run, so negative 2 over 1. I'm going to start at my y-intercept, go down 2 over 1, again down 2 over 1. I get a line that I'm going to draw in. I used a green line for that one just so I can keep it straight from the next line that we're going to draw right now. The next line that we're going to draw is for the equation negative 3x plus 9y equals negative 6. So again, I want to put this in slope-intercept form first. So I'm going to add 3x to both sides. I get 9y equals 3x minus 6. I would need to get y by itself, so I'm going to say divided by 9 for all of these here. Divided by 9. So I get y equals 1/3 x minus 2/3 is what I'm going to get here. So now when I graph it, it's a little bit different because it's not an exact number, whole number. So I have negative 2/3 is my y-intercept. So I'm going to go down on the y line, down here to negative 2/3. So about there is where I'm going to start. So that's my y-intercept. I'm going to put my first point there. And now my slope is telling me rise over run, 1 over 3. So I'm going to go up 1, so a little bit higher than the origin there, over 1, 2, 3. So my point is going to be there. Again, up 1, over 1, 2, 3. So this is a little bit different than what we've been doing before. So now I'm going to draw my line in. And I'm using the red pen for this one, so I keep my equations, I keep track of which equation is which. So now that I have this, you can see for this example why we still need to plug in that point to see if it actually works for us or not. So it looks like it crosses here at this point. This point, if we look for the coordinate pair, would be 2 for x, so 2, 0, because I don't go up or down any. And that's where it looks like the two lines cross. I need to plug that in to double check because it's not exactly straight here with that. So my equation was y equals negative 2x plus 4 for our first equation. So plug in 2, 0, which is x, y. So for y, I'm going to plug in 0 equals, let me slide this up a little bit. So y equals 0, plug that in, minus 2 times x is 2, plus 4. Negative 2 times 2 gives me negative 4, plus 4 equals 0. Bring this down, 0 equals 0, so that is a solution. That checks out. My red equation, I had y equals 1/3 x minus 2/3. I'm going to plug in again. So when I do this here, I'm going to plug in 0 for y, 1/3 x, I plug in 2, minus 2 over 3. 2 times 1/3 gives me 2/3 minus 2/3. That's going to give me 0. So if I bring everything down, again, I can see that 0 equals 0. So this checks out. So a solution for both of these lines up here would be 2, 0. So my answer would be 2, 0 is a solution for both of those graphs, both of those lines.